Factoring trinomials of the form ax squared plus bx plus c. Factoring a trinomial like this first one, 2x squared plus 7x plus 3, takes a slightly different strategy than factoring the second trinomial. And that's because in this first one we have an a value. So we label the coefficients in the constant a, b, c. So here a is 2, b is 7, c is 3. And in the second trinomial, a is equal to 1. And so we were able to do these, what we call simple trinomials, in the previous videos that we did. And now we're going to see that we have to make our strategy a little bit different to do what we call messy trinomials with an a value that is not equal to 1. I'm going to show you this strategy by working through this example. So to begin with, what we do is we multiply a times c. So here's our a value, and here's our c value. So we multiply a times c, that's going to be 2 times 3 is 6, positive 6. Now, just like before, we find two factors of a times c that add to b. So we go to 6, and we list some factors, and we're thinking about 7. Well, 6 times 1 is equal, or sorry, 6 times 1 is equal to 6, and they add to 7. So we're going to pick positive 1 and positive 6. So this is where things get a little bit different. We're going to write that bx term as factor 1 x plus factor 2 x. So 7x we're going to write instead as 1x plus 6x. These two factors that we figured out in the previous step, we're using them to split apart that bx term. So here in our polynomial, we're rewriting the polynomial as 2x squared plus 1x plus 6x plus 3. So we've split apart that bx term. And now we use factor by grouping. So here's our first group, and here's our second group. So this first group, what do they have in common? Only an x, so it's x times 2x plus 1. And in the second group, plus, what do we have? Well, there's a 3 in common, and that's all. So 3 times, leaving us behind 2x plus 1. And now you can see that just like we expect when we factor by grouping, we have two binomials that are shared in each of those terms. So we factor out that common binomial. That's 2x plus 1 times x plus 3. And so there is our factored polynomial. But of course, the last thing we should always do is check our answer by foiling. And so let's FOIL that out. And we get 2x squared plus 6x plus x plus 3 is equal to 2x squared plus 7x plus 3. And that's our original, so we've done it correctly. So let's go through another example. So the first thing we do is we multiply the a and c, and we get 6. So that's positive 6. We now need to find two factors of positive 6 that add to 5, positive 5. So there's not too many factors of 6, so I can pretty quickly see that this should be plus 2 and plus 3. They multiply to 6, they add to positive 5. And we're going to use these to replace that 5x in our trinomial. We're replacing 5x with plus 2x and plus 3x. And this allows us to factor by grouping. And it actually doesn't matter what order you put them in. You could do plus 3 and x and then plus 2x, or you can do the opposite way. You'll get the right answer either way. So we're factoring by grouping. In the first bracket, all that's in common is x, so we have 3x plus 2. And in the second pair here, there's actually nothing in common between 3x and 2. So what we essentially do is factor out a 1. So we have plus 1 times 3x plus 2. because pulling out a 1 doesn't do anything to the bracket. And now we complete our factor by grouping, and we factored the trinomial. So once you get quick with the steps, it actually becomes a pretty quick process. And the last thing to do, check with FOIL. 3x squared plus 3x plus 2x plus 1, or sorry, plus 2. 2 times 1 is 2. And that simplifies to 3x squared plus 5x plus 2. Perfect. The last example I wanted to show you is what happens when these numbers get a little bit bigger. So first of all, there is no common greatest common factor that we can pull out. I looked for a second, I tried, are each of those divisible by 3? And the answer is no. So we're stuck with having to go through this process. So 18 times 15. I'm using my calculator here, and I find that it's equal to 270. So in order to factor this, we need to find two factors that multiply to positive 270 but add to negative 37. So we're looking for two negative numbers, and I mean they could be anything. So what I do is I just go to my calculator and I start dividing 270 by stuff. Like what happens if I do 270 divided by 30? Well, I get 30 and 9. So I could try negative 30 and negative 9. And do those add to negative 37? No. Actually kind of close though, but they don't work. So I just have to try other numbers. Maybe 270 divided by 15. Oh wait, we don't have to do that one because we know that the other number is 18. Those don't add to 37. So 270 divided by 10. Well, if I do 270 divided by 10, I get 27. So two factors are negative 10 and negative 27. Those multiply to positive 270, and look at that, look, they're going to add to negative 37. So now we can just start flying through this process. Negative 37 splits up into negative 10x minus 27x plus 15, and now we're ready to factor by grouping. In this first set, we can pull out a 2x, leaving 9x minus 5. And in the second bracket, I'm going to pull out a negative 3, and that will leave me with negative 27 divided by 3 is 9x, and plus 15 divided by 3 is negative 5. Good, so it worked out. I have those common brackets on each term, so I can factor that off of each term, leaving me with 2x minus 3 in the second brackets. And so there's my completed answer. And again, we could FOIL this to confirm that we've done this correctly.